a GCSE Computer Science Syllabus Statement 1.4a show understanding the need to keep data safe from accidental damage, hardware and software faults, and human errors. So, it's important that before watching any of the topic 1.4 or topic 1.5 videos, you need to watch security aspects from topic 2. Don't know why they put it there. They should have just put it here, honestly. But you're gonna have to watch that because it contains stuff like hacking, viruses, and spyware, which we're gonna be using here as well. So it's good that you know about that. So once you've done that, we can continue with this. So let's start with accidental loss of data. So accidental loss of data is when you accidentally lose data. So example could be if you're clearing out your computer to save some space, and then you accidentally delete a file, then which is important, then oh no. So here's some safeguards. First one, backup data in case of loss or corruption. This is an important one. In fact, this is a safeguard for each and every one of these points here. And this is because, backing up data is really important because you always have a spare copy if your file gets lost, corrupted, or whatever. Save data regularly. This is important because, say you're working on a Word document, or you're working on something, and then you write 2 or 3 paragraphs, and then something happens, such as, I don't know, the power to your computer goes off, or, the program crashes, then, you would have lost some of that data. So it's good that you save regularly to prevent this from happening. So for when I'm making these slides, I always save after the end of every sentence. Use passwords and user IDs to restrict access from unauthorized users. Now this is a bit weird because, what does this have to do with accidental loss of data? Well, think about it. Like if you restrict access from people who don't know how to use a computer, then it's good so that there is less chance of them accidentally deleting the file. Yeah. Hardware faults safeguards. So a hardware fault is a fault in the hardware, such as like a head crash on a hard disk drive. So it's important that you can save your data in case this happens. So again, backup data. It's good if you do that. Save data regularly. Same point that we had last time. Also, you could use a UPS. And what this is basically a power supply that's uninterruptible. So if the power goes off, you can still keep your data because this power supply is still running. And use parallel computer systems as backup hardware. So that's a good one because you have 2 parallel computer systems. So what you do with one computer system will also save in the other, or something like that. I'm not entirely sure, but I think that's what it means. So it's good if you do that. Software faults, again, backup data, it's always there. Save data regularly. So if your software freezes or crashes or whatever when you're still working on that document, then it's good if you save, because there's no harm in saving. Incorrect computer operation safeguards. So incorrect computer operation could be stuff like if you incorrectly shut down your computer, for example, or if you remove your thumb drive when it's while data is being transmitted. Again, backup is really important, and go through correct training procedures to be aware of the correct operation of computers. Now, this is this is a bit weird because, you know, I mean, who doesn't really know how to use a computer? But still, like, it's good to know these principles so that you know, like, you basically, you know your stuff about computers. So that's about it. This is quite a short video. But I'm just going to talk about security itself for a bit, as in the topic. So what we're going to be going through after this is we're going to be going through, I think there's firewalls, then security protocols, and what was that? Oh, whatever. Security protocols, encryption, and some other, like, some attacks such as phishing and farming, as well as DOS, and also authentication. And then we look at all this, and then we apply it to real life scenario, like we did with input and output devices. So that's pretty much it. And then once we do that, we move on to topic 1.5, which wraps the entire theory of computer science up. So yeah, that's it.